is our presentation on Experiment 8 involving pH titrations. My name is Hannah Suter and this is my partner Sarah Fountain. Our objectives of this experiment were to generate pH profiles using result tables and graphs. We determined the pKa using the tables and the graphs, and we determined the Ka from calculations using that. We also determined the molecular weight of the unknown acid. Some background information on the experiment. What is neutralization? It is the reaction between an acid and a base that results in water and a salt. And some pH profiles, the general results, a strong acid and a strong base results in a pH of 7 at the equivalence point. And the weak acid and strong base results with a pH of greater than 7 at the equivalence point. The strong acid and weak base reaction results with a pH less than 7 at the equivalence point. And the weak acid and weak base reaction, you need more calculations to determine where the pH will be at the equivalence point.
For an experimental, we each started by obtaining an unknown weak acid solid. Then we set up the apparatus shown in the picture. We pipetted 10 milliliters of HCl into a beaker and added deionized water until it covered the pH electrode. We filled a burette with NaOH and recorded all the concentrations of the solution. We titrated 1 milliliter of NaOH into the beaker, and each time we titrated, we recorded the pH level and the volume in our results table. We kept titrating small amounts of NaOH into the beaker until the pH changed by greater than 0.2 pH units. At that point, we decreased the amount of NaOH we added until we passed the equivalence point, and then we increased the amount of NaOH until we stopped at a pH of 12. In the second experiment, instead of using HCl in the beaker, we used acetic acid. And then in the third and fourth experiments, we measured 0.2 to 0.25 grams of each of our unknown acids and dissolved them in water and used those in the beakers.
Here are some of our results. As you can see, you don't need to look at all of the numbers, but in the end of these, it ended up with 20 milliliters of the NaOH required for both of them. And that's the strong acid, strong base, and the weak acid, strong base. And here, the results are different. That is the first unknown acid, and that is the second unknown acid. Here's our graph for the strong acid and strong base, and you can see that the pH is 7 at the equivalence point, right in the middle. And the weak acid, you can see that it's higher. And here's our unknown, our first unknown, and our second unknown. Here are results, and the pKa's you can show, and then it will show the pH that we found.
These are our calculations. This is a sample calculation to find the Ka. It was of our strong acid and strong base, and we got a Ka of 4.78 times 10 to the negative 3. This is a sample calculation of our percentage error, and our percentage error was 44.45%. This is a sample calculation of our molar mass of our unknown number 2. And we got 153.75 grams per mole. And for our unknown acid number 1, our pKa was 5.11, and our molar mass was 203.96 grams per mole. This compared to the potassium hydrogen phthalate with a pKa of 5.51 and a molar mass of 204.2. For our unknown acid number 2, we got a pKa of 3.25 and a molar mass of 153.75 grams per mole. This compared to mandelic acid with a pKa of 3.85 and a molar mass of 152.15.
Here are our reactions, and it just shows the complete anionic and overall equations resulting from the hydrochloric acid and sodium hydroxide and the acetic acid and sodium hydroxide.
We did not calculate the pKa and Ka for the HCl because it dissociates completely in an aqueous solution.
To compare the initial pH and the pH at the equivalence point of the strong acid, strong base, and weak acid, strong base, as you can see at 7, at the strong base, strong acid, strong base, at the equivalence point the pH is 7, at the initial pH is lower, and it's at 2. And on the weak acid, the initial pH is higher, and so is the equivalence point. And that agrees with the general pH profile. To compare the number of moles of base required to neutralize the strong acid with the number of moles of base required to neutralize the weak acid, they are the same because as long as the volume and the concentration are the same amount of base will be required because they're going to a pH of 12. There are references. Any questions?